Simplify this whole thing, this entire thing, it gets simplified to x just equals to 30. Is that okay? Now the two paths merges, okay? After they merge into one single path, then our only conclusion is x equals to 30 or x equals to 31. In other words, if this program is having a problem because x equals 28 is the wrong value, now without running the program again, just by analyzing the logic of the code, you can deduce by the time, before this point here, at this point, x can have possibly one or the other value. One is 30 and one is 31. Okay? And that's a debugging technique. Okay? It's a debugging technique by observing the value or the values of one or more variables at one point. How far can you push the logic backwards and say, because I know this at this point, I can actually use deduction and find out that, okay, this condition has to be true at this point of the program's execution. Yep.
Could we just put breakpoints at every we're debugging this program? Could we put breakpoints at each?
Yes, you can use breakpoints, but breakpoints are only useful when your program is deterministic. Okay? Deterministic means every time you give the program the same parameter, the same input file, the same input conditions, it always behaves exactly the same way and give you the same result or the same bug or crashes exactly the same way. That applies to some programs, but not all programs. Okay? In some programs, you have one shot, and that's it, because you cannot reproduce the same condition again. Okay, I can give you a very simple example. Let's think about the mouse driver software of your operating system. Okay? When are you going to move the mouse? How far are you going to move the mouse? When are you going to click something? Are you always going to click something when the mouse is over this point? Are you always going to click the mouse when it's over this point? We don't know. That's undeterministic, or you can call it by chance. Okay? So that means, if you have a bug with your mouse driver software, it can cause a symptom to happen, but you may not be able to reproduce the symptom in a year. Or it can happen the next second. There's no telling when the same symptom will occur again because, you are depending on many factors all combining at the same time, and those factors may not combine ever again. Okay, so in those situations, if you can take a snapshot when the program has misbehaved and use this technique to go backwards, by deduction, you may still be able to find a bug without having to reproduce the problem, and this time put a breakpoint earlier. So you are correct. If you have a program that is completely deterministic and you can feed it the same test case over and over again, yes, what you can do is simply to put a breakpoint earlier, so that way you can stop the program at an earlier point and then take a snapshot of the variables at that point. But the other technique, going backwards just by deduction, is also helpful when a program is not deterministic. Yep.
Might also add that you have to be able to know what the answer should be. It doesn't do you any good at all to put a breakpoint and go, okay, it's 30 or 31. If you can't figure out what it should be, then you may not be able to find the error even if you're looking at it.
Yeah, actually modern technology encourages bad programming practice, and I can explain why. Because just like what you said, if the program crashes at some point, like here, when it's not behaving right at this point, you can just go back into VB, the IDE, put another breakpoint earlier, run the program again using the same test file, and then when the program stops, then you can say, oh, I know for sure x equals to 30 at that point. But you can do that only because, one, VB is easy to use. Two, you have the PC available to you and you don't have to share that with other people. If you think about 30 years ago on the mainframe, okay, you don't own the mainframe, for one thing. Two, running any program on the mainframe costs money. Okay, so you cannot really just resubmit a job and say, oh, I want to run the job again. Well, wait until tomorrow. Okay. And that's why in the good old days, people look at the output of a program, it is not right, and they try to use the entire day to figure out where the bug is without rerunning the program, because they cannot rerun the program again, to fix bugs like that. And that's why older programmers, back in those days, they use logic a lot more than programmers today, because programmers today have all these tools. They're really fast, they're really convenient, and they don't have to rely on as much brain juice, to debug a program, which is both good and bad. It's good in a way, but it's also bad in a way, because it really makes certain types of programmers lazy and just try to use the trial and error method to debug a program, and that's just not the way to do it. Okay. All right. So what we have now is we have a strong suspicion, okay, that at this point x equals 30 or x equals 31. So the next step is to reverse again, and then this time we go forward. Okay. By means of going forward, I mean, if I say that pre-32 is exactly x equals 30 or x equals 31, and use all the derivations, rules, by the time I get to post-37, I should get x equals 28 exactly. Do you understand what I'm trying to say? Yeah. Okay. So let's go ahead and do that part, because that part is something that we can actually do step by step and using analytical methods. Yep.
Just a quick question on the mod. If I understand it right, so let's just say, and just for our purposes, x is 14. So 14 divided by 2 would be 0.
As a remainder of 0.
Well, remainder is 0, yes. Mm-hmm. So that would make it even. And then if it was like 15, then that would be an odd because there's a remainder there. Is that correct?
Because the remainder is 1. Yep.
Okay.
The remainder is non-zero.
Okay.
Technically speaking, there's always a remainder. The question is, what is the value of the remainder?
Yeah.
Yep. Okay, so let me just make sure I save the file first. Even though it's empty, that means I basically reserve a spot in today's files. Okay. So now we are moving forward. Okay, I think moving forward is actually easier because it's just a matter of, okay, which rule do we apply and what is the result of applying that rule. Okay, going backwards is a little harder because we don't have any rules that we have talked about that applies to going backwards.
Before you do that, can you write down the rationale? Because we can't do the drawing, can you write it down how it should be worded?
Yeah, I can do that. Okay. Okay. But the way I put it may not be the same way that you want to put it.
Sure.
Okay, so I'll just write it down the way that I would have put it if I were to answer this question. Okay, so that is given. Okay, so you always want to start with something that is given so that I know that you're not making it up. Okay, so you have a connection from your piece to the question itself. You always want to start with that. It's only one line, doesn't take a whole lot of space or time. Okay, so you can basically say, post 36 is also x equals to 28 because if you want to write it down, you can just write down nothing happens after line 36. Okay. Then you can say pre-36 is x equals 31 because line 36 subtracts 3 from x. Is that okay so far? So that's kind of briefly summarized, the rationale that we were going through. Okay. The other branch to get to line 36 means that x is greater than 30, and in this case, x equals 28 on line 35. Okay, I don't quite know how else I can put this part here. In other words, I'm explaining this condition here.
Less than 30.
Oh, less than or equal to, that's right. Sorry about that. I can just put a not in front of that. Means exactly the same thing. Yep. But technically speaking, that's exactly what it is because we are negating the condition, and that's how we can take the else branch to bypass the operation itself. So this means on line 35, the precondition of line 35 can be either. Okay, it's possible that x is 28 and x is less than or equal to 30, or the other way. The other way is x equals 31 and x is in fact greater than 30. Are we doing okay so far with this?
Can you kind of explain that? Just that last line you did?
Okay, because we are merging the two lines, merging the two branches.
Okay.
One branch is coming back through this part here.
Okay.
If we go through this part, x equals 31, but we also know that x is greater than 30 because otherwise we will not be taking the true branch. And then the other branch, through this way means that x equals 28 has still to be true because we didn't do anything to x, throughout this entire branch. But because we are going through this branch, we also know that x is greater than 30 has to be false, which means x has to be less than or equal to 30. Okay? And if you look at this one here, then you can say that this simplifies to 335 is just saying that x equals 28 or x equals 31. Because of the reason that we talked about on the other side, it basically has the same reasoning.
Yeah.
Okay, and then we can say post 34 is the same as pre-35 because the two conditional statements are sequential. They're one is completely after the other one, and that's why the precondition of one is the post condition of the earlier one. Is that making sense so far? Just making connections between the points. Okay, and that also means that post 33 is the same as post 34 because nothing happens to x between line 33 and line 34. There are no additional statements to change x between those two lines. But that means pre-33 is two things. One, pre-33 means that x mod 2 has to be 0. That comes from the conditional statement itself. At the same time, we also know that that's the, we know that post 33, which is the same as this part here, is the result after we add 1 to x. So before we add 1 to x, we have to make sure that we say, oh, okay, before that, before line 33, x should have a value of 30, or x should have a value of 27. Because line 33 adds 1 to x. Is that okay? Sort of? Okay. The other branch, the false branch, means that x mod 2 does not equal to 0, because if it does equal to 0, I would have taken the then branch, the true branch. And also, post 33 will still be true because nothing happened between, in that branch. Okay, so we'll say because there is no operation in the false branch. Is that okay? So now we can merge the two paths. So when we merge the two paths, then we are talking about pre-32. So pre-32 is pre-33, or the other one, which is x mod 2 is not 0, and post 33. So now we have a big mess here that we have to expand and simplify. What is pre-33? Pre-33 is this junk here. So we'll go ahead and copy that junk, and then we'll talk about how to simplify that. One more, and then post 33 is